All right, so let's dive right in. We're going to unpack one of those persistent engineering headaches in connectivity.
Mhm.
How do you get high-speed USB data to travel a long distance? We're talking 10 gigabits per second over 25 feet without the signal just falling apart.
Yeah, standard copper just can't do that reliably.
Exactly. So today we're using a really fascinating piece of hardware as our blueprint. It's the Kramer CLS-AOCU32-AC25 cable.
And it's a great case study. Now, this specific model is a legacy product. It's discontinued, but the technology inside is still a critical reference point.
Right.
The mission here isn't just about delivering data. It's about guaranteeing that 10 GBPs throughput over distance, which, usually means you need bulky repeaters or an external power supply.
And this promises to get rid of that complexity. So we're going to focus on this core concept, the hybrid cable.
That's the key.
So what makes this thing tick? Let's start with the performance numbers. It's USB 3.2 Gen 2.
Which means it guarantees that 10 GBPs rate.
Yeah, perfect for those really bandwidth-hungry installs. Things like high-res USB cameras or maybe pro webcams, speakerphones in a big conference room.
And what's truly fascinating, and where the engineering genius really comes in, is the power.
Okay.
This is a 25-foot active cable running at 10 gigs, and yet it needs absolutely no external power.
None at all.
None. It's fully bus-powered. It draws everything it needs, which is less than half a watt, by the way.
Less than half a watt.
Right. Directly from the USB host device.
Hold on, so if it's pushing all that data over that distance, how can it pull so little power? Isn't that where long copper runs just fail?
That's because the heavy lifting for the data isn't being done by copper at all.
Ah.
The secret is the construction. This is a true hybrid cable. So you have copper elements that handle the, essential low-speed signals and, most importantly, the power transfer.
Okay, so the copper is just the lifeline.
Precisely. The actual 10 GBPs of bandwidth is transferred optically over fiber.
So the fiber is the speed engine. That makes so much more sense.
Exactly. The data transmission uses a tiny, very low-power optical laser engine. Specifically, it's a 2-channel OM2 850 nanometer VCSEL array.
A VCSEL.
Right, a vertical cavity surface emitting laser. Just think of it as converting the electrical signal into little pulses of light.
And those pulses travel down the fiber optic channels.
Effortlessly. And that optical path is what maintains the signal integrity and allows for that incredible length and speed, all while keeping the power demand so low the host can handle it.
That is a beautiful solution to the speed and distance problem. And it also, I see, maintains strong backward compatibility. It handles 3.0, 2.0.
And even 1.1, which it supports up to 50 feet.
Yeah.
Which is crucial for system integrators.
But, and this is but for you to consider, there is a crucial trade-off baked into this design. This cable is strictly for data transfer only.
Yes, that is the functional sacrifice you make. It's explicitly noted as not being for charging.
So no charging your phone with it.
No. And no ALT mode signal. That means you can't run DisplayPort or HDMI over it. You are trading charging and display flexibility for pure, unadulterated data distance.
Which really tells you this is for a specific job. Purely peripheral connectivity, not some universal dock.
Yeah.
And since it's designed for, say, permanent installations, running under floors or behind walls, the physical specs are just as important.
Absolutely. This isn't your standard consumer wire. I mean, it's thin, only 4.8 millimeters in diameter.
That is tough.
Very tough. Look at the crush resistance figures. 500 newtons short term and a sustained 100 newtons long term. This thing is engineered to survive being stepped on or pulled through a tight conduit without damaging that delicate fiber inside.
So what does this all mean when you boil it down? This deep dive really shows the serious engineering needed to push past copper's limits.
Right.
By using optical tech for the speed and distance and just dedicating the copper to low power signaling, integrators get that 10 GBPs over 25 feet and they completely eliminate the need for those bulky repeaters or power supplies.
It simplifies the whole installation.
And maintenance, too.
And if we connect this back to the bigger picture, it raises an important question for you. When does that strategic advantage, getting rid of the power brick, outweigh the sacrifice of losing charging? And what specific application truly needs that long-term crush resistance of 100 newtons in a permanent install? Something for you to consider the next time you're designing a system that relies on a critical, long cable run.